you're going to understand 100% the CPU circuit. I will teach you everything about how to diagnose, track voltages, follow signals, etc. in the CPU circuit. So as you can see here, this is the CPU control IC. Here we have MOSFETs, 10-10 capacitor. So this is the first channel here, and this is the second channel. Do you see here this part here? This is the CPU IDs, because in order to generate the VCC core to feed the CPU, the IC should receive first these IDs, as you can see, and based on these IDs it will generate the control signals for these MOSFETs in order to generate plus VCC core. So let's first take a look to the CPU circuit and then go step by step on how to diagnose, how to track and follow voltages. As I told you, this is the IC. Here we have MOSFETs, here we have ceramic capacitors, this is 10-10 capacitors, and in the other side we have inductors. Okay, so each inductor means one channel. So this is the first channel and this is the second channel. So here always the ceramic capacitors means we have the input. We can ever check using the multimeter. So let's zoom out a little bit. So here we have the CPU circuit. Let's check if these ceramic capacitors are the input or not. So here we have the input. Do you see the power jack? As you can see here we have the first switch, the second switch. So if we check between this switch here, okay, and these ceramic capacitors, we get, as you see in the multimeter, very low resistance, and of course we get a continuity. Means this point, this switch is connected directly to the ceramic capacitors. Means here we have 19 volt, it will pass directly to the side. Of course we select here the buzzer or the continuity option. So as you can see, these ceramic capacitors are connected to the input signals in this side, as you can see here, and to the ground in the other side. So here we have the ground. This wide area means the ground. We can even check if we put one probe here and put the other in the ground, as you can see in the multimeter. So here the 19 volt will pass through the ceramic capacitors to be filtered. Okay, so when capacitors are in parallel means they have filtering purpose, and when you find ceramic capacitors in series means they are used for coupling purposes. I'm going to explain to you everything in the next slides. So the 19 volt will pass through the ceramic capacitors and then goes to the drain. Here we have the drain. Do you see here? So we have the same path here. If we check between this MOSFET and those capacitors, as you can see, we have a low resistance. Do you see? Means we have connection. So this is the drain. For beginners, of course, the drain, all 4 pins are connected together, as you can see. So all 4 pins are connected together. So here we have drain, and these 3 pins are source. If we check, of course, for beginner, the 3 pins are connected also together. And we have the gate. Do you see here we have the gate? If we check this pin, we have to find a continuity with this IC. Let's check. We have to find a direct continuity, because this IC is the IC that controls that MOSFET. Do you see? We have a direct continuity between this pin and this pin. Please, before diving into the course, we'd like to give a huge thank you to the sponsor for this video, PCBWay. PCBWay offers many services ranging from PCB production and assembly to 3D printing and a variety of materials, CNC machining, sheet metals fabrication, injection molding, and more. PCBWay makes it easy to get custom parts for your project, and if you don't like to work a lot with a soldering iron, they can even assemble your PCBs for you. That's the PCBWay. Now back to the video. Even for this one, for example, here we have the gate. if we check also this one, let's check between the gate here and this IC. Do you see? We have also continuity. For 4 MOSFETs are controlled by this IC. So the 19 volt will pass to the drain, and then after receiving the control signal here in the gate by this IC, this voltage, the 19 volt, will be transformed to plus VCC core. So VCC core is about 1 volt. Basically, it is between 0.7 volt and 1.5 volt. Do you see? The source of this MOSFET is connected to drain of this MOSFET, and then this MOSFET is connected to the ground. I will show you all this. Just please stay tuned until the end of the video. You gotta understand everything. So this MOSFET is connected to this one. This one basically here is for it removes the extra voltage and extra energy. Okay, that's why it is connected to the ground. Okay, here the source here is connected to the ground, as you can see. Here we have the source, here we have the drain. Please, for beginners, always remember, do you see here we have this dot here and this white mark here? Okay, it means this is the source. So this dot means this is the pin number 1, 2, 3. Always 3 pins are for source. Here we have gate, and 4 pins are for drain. So here also is connected to this 2 tantalum capacitor. If we check, do you see? We have connection. We have also here connection. Okay, so this tantalum capacitors, as I told you before, is in parallel. Always when capacitors are in parallel means they have the filtering purposes. Okay, do you see here we have TC means tantalum capacitor. Okay, so TC tantalum capacitor. For this capacitor we have C as a reference, and for MOSFETs we have U. It could be Q or U, no problem. By the way, I will give you a very simple trick to check if the IC is bad or not. You can just check using your finger. If you feel that the IC is very hot, above normal, means the IC is shorted. Or you can just check the ceramic capacitors like this around the IC. If you find that many of those ceramic capacitors are shorted, means you have a shorted IC. Of course, it could be the ceramic capacitors, but above 80% the IC is the shorted component. Okay, and of course, guys, if you want, for example, to check or to take measurement here, do not take it directly in the IC here in these pins. You could make short circuit. Please use extension. For example, if you want to take measurement in this pin here, do you see we have this extension until this resistor? Do you see? So this resistor is connected with this pin. We can even check, as you can see in the multimeter. Sorry, do you see? So this pin is connected to this resistor. So if you want to check, for example, to take measurement here, try to use the extension and take measurement here rather than here, in order to avoid short circuit. The same, do you see, for example, this pin here? If we follow this path here, we have this resistor here, and also we have this point here. So take measurement here rather than take it here, guys. Okay, so let's see the other side. So in the other side of the processor, we have, of course, the inductors, and the inductors basically is where we can make sure that the VCC core is generated. So if you want to check if the VCC core is generated or not, you can take a measurement here directly into inductors, as you can see. So please, guys, do not miss this explanation. I'm going to teach you how plus VCC core is generated from A to Z and step by step. Please make sure you stay tuned, because this is very important. So here we have the CPU. Okay, let's begin with the CPU. Okay, here we have the CPU or the processor, and over here we have the IC or the control IC that will generate So this control IC basically will generate plus VCC core. So over here we have MOSFET, the first MOSFET or the higher MOSFET, and here we have the lower MOSFET. So let's see Q1 and over here Q2, and here basically we have inductor, and over here we have two ceramic capacitors. Let's see tantalum capacitors. Okay guys, so this is polarized capacitors, and then here we will get plus VCC core. Please pay attention, I'm going to teach you something that is very important for you as technicians and in general. So here we have drain, 4-pin for drain, so of course we need B plus or plus B, about 19 volts depending on the type of the computer or laptop. So here we have the source, of course, connected to drain of this MOSFET, and then we have source connected here to ground, and then we have the gate here, okay, J. Here we have drain, here we have source, also here we have the gate G, here source, and here drain, and of course we need here some ceramic capacitors that are connected to the ground, C1, C2, and here C3. This is basically for filtering. Okay, so this is good. So for this IC, before generating the control signal to control these two MOSFETs, it needs first to receive about 6 or 7 signals here. Okay, we called it CPU IDs. Okay, CPU IDs or VID. So each CPU has specific IDs. So based on these IDs, the IC will know the exact voltage of the CPU, because the plus VCC core or the CPU voltage, okay, remember guys, this is always, the CPU voltage is always between 0.7 volts, okay, to 1.5 volts, of course, plus. Good. And each CPU has an exact voltage between this range. Let's see the CPU has as a voltage 1.2 volt, for example. So based on these IDs that this IC will receive, it will know that the CPU need 1.2 volt as a VCC core. So this IC now should generate plus 1.2 volt here. So now this is good. It will send an exact control signals to this MOSFET. So here we have 19 volts that will pass in this direction and will be present here. And once this MOSFET receives the control signal, this 19 volt here will be 1.2 volts. Okay, and then this 1.2 volt will pass through this inductor. We have inductor L, and then will be filtered by this tantalum capacitor. Okay, and then we will get plus VCC 2 volt. Let's assume, for example, that we didn't get 1.2 volt, we get 1.3 volt, for example. So here this MOSFET will eliminate 0.1 volt here to the ground in order to get always 1.2 volt. Okay guys, so this is how the CPU works. And of course for the CPU it could have another channel, because basically the CPU has more than channels. So here if we put Q3 and Q4, and here we have inductor, we have other so MOSFETs or capacitors connected, so TC, and so the same. So here we have inductor, here we have capacitors, and over here we have MOSFETs, of course, connected to the same B plus here, okay, or plus B. And of course the IC, here we have the gate, is always the control IC for all channels. So this channel and this channel are the same. They have the same working principle, or the same purpose is to generate plus VCC core for the CPU. So guys, this is how the CPU works. So please don't forget to like the video, to subscribe if you're not yet subscribed, and to hit the bell icon for future videos like this one. And please share the video. And for anyone who want to join me in my Patreon page, you are very welcome. In order to, if you want to accelerate your learning, and you will find all links in the description. So thank you very much, and see you in the next video.